Alright, today we're going to start talking about geometric sequences and series. Alright, a geometric sequence, if you look at this picture, there's one square here. Okay, then they break it up into 1, 2, 3, 4, 5 squares. And then each one of those is broken into 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then each one of these are broken into 5, 1, 2, 3, 4, 5. And then each one of those are broken into 5. And you can see this pattern, 1, 5, 25, 1, 25, 6, 25. Each term after the first is obtained by multiplying the preceding term by a constant amount, namely in this case 5. It's increasing by multiplication, whereas our arithmetic sequences increased by addition or subtraction. Okay, increasing by multiplication, or decreasing by division, if you will, is a geometric sequence. Okay, just like our arithmetic sequences were linear, when you plotted their points, you got a straight line. Geometric sequences are exponential. They look like a rumor spreading. Okay, now, to get your common ratio, remember in arithmetic, to get your common difference for arithmetic, you took A2 and you subtracted A1. To find your common ratio, in other words, when you're doing geometric, you're finding the common ratio R, and you get that by dividing A2 by A1. So if you look at our sequence from before, 1, 5, 25, 125, 6, 25, if you divide any of these, 5 divided by 1 is 5, but you could do any two. 625 divided by 125 is 5. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So the common ratio here is multiplying by 2. You multiply by 2 to get the next one. Here, negative 12 divided by 6 is negative 2. So to get the next one, you're multiplying by negative 2. And here, you're actually decreasing, you're multiplying by negative 1/3, which is the same as dividing by negative 3. Okay? Again, if you plotted the points, the terms would be 1, 1. First term is 1. Second term is 5. Third term is 25. Fourth term is 125. Sixth term is 625. Okay, and you plotted those, you can see when I graph them, it looks like an exponential function. Whereas when we graph the arithmetic ones, it looked like a line. Alright, so to find the common ratio, it's very simple. You divide the second term by the first, third term by the second. If the quotients are the same, it's geometric, and that quotient is your common ratio. So it says, if the given sequence is a geometric sequence, find the common ratio. So what I do is I start dividing. 12 divided by 4 is 3. 36 divided by 12 is 3. You can keep trying, but it's pretty clear. You don't have to try them all, but you can every time you get 3. So yes, this is a geometric sequence because I get the same thing every time, and the common ratio is 3. If I wanted to get the next term, I'd take 324 and multiply by 3. It'd be 972, and I could keep going. Okay, this one, don't freak out on fractions. If I take 8/3 and divide it by 4/3, keep, change, flip, the 3's cancel. That's 8/4, which is 2. Okay, try again. If I do 16/3 divided by 8/3, keep, change, flip, I get 16/8, which is 2. And if you notice, that's what they're doing. They're multiplying. The denominator never changes, but the top is changing by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. But the denominator would stay the same. Okay, here, if I take 1/12 and I divide it by 1/8, keep, change, flip, I get 8/12. I could reduce it, but let's just see what happens. 1/16 divided by 1/12, keep, change, flip, that would be 12/16. So if I reduce by 4, that'd be 2/3. Here by 4 would be 3/4. I don't get the same thing my common ratio is not the same, so this is not a geometric sequence. Okay, so there is no common ratio. Alright, hit pause, come back when you're ready, and hopefully you got -3. If I take -9 divided by 3, I get -3. 27 divided by -9, I get -3. -81 divided by 27, I get -3. The common ratio is -3. Hit pause, come back when you're ready, and hopefully you got it's not geometric. It's the same one we just did. Okay, if I take 1/8 divided by 1/6, keep, change, flip, you get 6/8, which if I reduce by 2 would be 3/4, so this one's simple. Check again, 1/10 divided by 1/8, keep, change, flip, you get 8/10. If I reduce, that's 4/5. These are not the same, so it is not geometric. Alright, writing the terms of a geometric sequence. Find the common ratio, then multiply the preceding term by the common ratio, and that's the next term. So it says, write the first 6 terms of the geometric sequence with first term 6. So they want that one and second, third, fourth, fifth, sixth. And it says it has a common ratio of 1/3. So to get the next term, I take 6 times 1/3. 6 times 1 divided by 3 is 2. To get the next term, I take 2 times 1/3, which would be 2/3. To get the next one, I take 2/3 times 1/3, which would be 2/9. To get the next one, I take 2/9 times 1/3, I get 2/27. To get the next one, I take 2/27 multiplied by 1/3, I get 2/81. Right? Yeah, 2/81. And there would be my first 6 terms of a geometric sequence with the first term 6 and common ratio of 1/3. Okay? Alright, you write the first 5 terms of the geometric sequence. They're writing it a little funny here. Probably should have shown an example. Is there not one in there? Weird. They're writing it a little funny. Okay, they're saying to get the next term in the sequence, hold on, let me make sure I have my pen. To get the next term, you're going to take the last term and you're going to multiply by -8. So they're telling you the common ratio is -8. Alright, hit pause, come back when you're ready, and hopefully you get this. So if my first term is -5, to get my next term times -8 would be 40, times -8 would be -320, times -8 would be positive 2560, times -8 would be -20,480. Alright, so it says, consider the geometric sequence whose first term is a sub 1 and whose common ratio is r. If we're looking for a formula for the general term a sub n, let's begin by writing the first 6 terms. The first term is a sub 1. The second term would be a sub 1 times the common ratio. Then the third term would be multiplied by 2 common ratios, 2 copies of the common ratio. So it's not 2 times r, it's r squared. Then 3 copies of r, then 4 copies of r, then 5 copies of r. Notice that when you're finding the 6th term, your exponent, you got 5 copies of the ratio. When you're looking for the 5th term, you have 4 copies of the ratio. 4th term, you have 3 copies of the ratio. 3rd term, you have 2 copies of the ratio. Okay, so just like arithmetic. So, if you want to find the nth term, you don't want to have to find every single one in between. All you do is you take the first term and you multiply by the common ratio n minus 1 times. So if you were looking for the 8th term, you would take the first term and you would multiply by 7 copies of r. Okay? Alright, so this one says, find the 8th term of the geometric sequence whose first term is -4 and whose common ratio is -2. So they're telling me n is 8. They're telling me a sub 1 is negative 4 and the common ratio is negative 2. If I plug that all in, the 8th term of this sequence would be the first term, which is negative 4, times my common ratio, negative 2, to the n minus 1. 8 minus 1 would be to the 7th. Now, when you type this, be careful. You've got to exponent first. So parentheses, negative 2, parentheses, caret 7 is negative 128 times negative 4 would give me 512. The 8th term would be 512. Your other option is to start off and do it by hand. First, second, third, fourth, 5, 6, 7, 8. Times negative 2 is 8, times negative 2 is 16, times negative 2 is 32, times negative 2 is negative 64, times negative 2 is 128, times negative 2 is negative 256, times negative 2 is 512. So you could do it long ways, but I think this is much shorter. The formula is really handy dandy. But if you forget the formula, you can always work it out by hand. Alright, so again, we want to use the nth term to find the formula to find the nth term of a geometric sequence. And it says find a sub 8 when a sub 1 is 2 million. The common ratio is 0.1, and if they want the 8th term, I'm going to take 7 copies of the ratio. So if I do 0.1 caret 7, that's 1e negative 7 times 2 million, I get 0.2. The 8th term would be 0.2. Okay? Alright, so you try this one, hit pause, come back when you're ready. And hopefully you get 375 over 128. So they want me to find a sub 11. A sub 1 is 3,000. The common ratio is 1/2, and if I want the 11th term, I need 10 copies of that ratio. So if I do 0.5 caret 10, I get 9.765625 e negative 4, which is 0.00097, blah, blah, blah. But while that's on my screen, times 3,000, and I get the 11th term is 2.9296875, which isn't there, so math, enter, enter, and you get the 375 over 128. Now, if you had a calculator that doesn't have math, enter, enter, in a multiple choice situation, what you could do is type this in. If you type 375 divided by 128, you get the 2.9296875. You could try the next one, 375 divided by 512, and you get 0.7324. This one, 375 divided by 256, is 1.46, blah, blah, blah. So it's got to be that one if you don't have a calculator that does math, enter, enter. Alright, so we've been talking about identifying a geometric sequence by looking for a common ratio. We saw that when we graph geometric, we get an exponential function. If you get a common difference, in other words, if you're adding to get the next term, it's arithmetic. If you're multiplying by the same thing to get the next terms, then it's geometric. Okay, and then we found how to find a specific term. Alright, so to write a formula for the general term, you got to find the common ratio, plug in a sub 1 and r, and you got it. Okay, so it says write a formula for the general term, the nth term of a geometric sequence. Well, the first thing I have to do, I know a sub 1 is negative 8. I got to figure out r, and then I can plug them in and I'm done. So to figure out r, I'm going to do my division thing. Negative 16 divided by negative 8 is positive 2. Negative 32 divided by negative 16 is positive 2. Negative 64 divided by my common ratio is 2. So to get the nth term, it's going to be the first term times my common ratio to the n minus 1. Done. There's my formula. Okay. For this one, I know my a sub 1 is 4. I gotta find my common ratio. So negative 4/3 divided by 4. Keep, change, flip, I get negative 1/3. 4/9 divided by negative 4/3. Keep, change, flip. I get negative 3/9, which is negative 1/3. So they are going to the same thing. So my common ratio is negative 1/3. So my formula is my first term, which is 4, times my common ratio to the n minus 1. And there's my formula. Alright, you do this one, hit pause, come back when you're ready. And hopefully you got 3. Okay, I know that a sub 1 is 4. I need my common ratio. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So my common ratio is 2. So my nth term would be my first term times my common ratio to the n minus 1. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 3. Alright, I know my first term is 2. I need a common ratio, so 1/2 divided by 2. Keep, change, flip would be 1/4. 1/8 divided by 1/2 would be keep, change, flip would be 2/8, which reduces down to 1/4. So my common ratio is 1/4. So my nth term will be my first term times my common ratio to the n minus 1. Alright, so it says a table shows the population of the United States in 2000 and 2010 with estimates given by the Census Bureau for 2001 through 2009. Show that the population is increasing geometrically. To do that, you have to do the division. So 284 divided by 281.4. 284 divided by 281.4 is 1.0092395517. Try the next two. 286.6 divided by 284. And you get 1.00915493, blah, 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 blah. Try the next one. 289.3 divided by 286.6. 289.3 divided by 286.6. You get 1.009154, blah, 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 blah. So, yeah, I get the same ratio every time. That shows that it's increasing geometrically. It says, write the general term for the geometric sequence modeling the population of the United States in millions n years after 1999. So the nth term will be the first term, 281.4 times my common ratio, which is 1.009, let's call it, to the n minus 1. Okay, then, so that's B. And C says, project the population for the year 2020. Well, now remember, N represents the years after 1999. So if I take 2020 and I subtract 1999, I get 21 years. So they want me to find the 21st term, which would be 281.4 times 1.009 to the 20th. So if I type that in, 281.4 parentheses 1.009 parentheses caret 20, I get 336.625815. So in the year 2020, the population was going to be close to 337 million people. Okay, in the U.S. Alright, so you do this one, hit pause, come back when you're ready. Alright, it says Ms. Patterson proposes to give her daughter Claire an allowance of 20 cents on the first day of her 12-day vacation, 40 cents on the second day, 80 cents on the third day, and so on. Find the allowance Claire would receive on the last day of her vacation. Alright, so A sub 1 is 20 cents, because that's what she's going to start with. The common ratio is 2, because if you take 0.40 and you divide by 0.20, you get 2. 0.80 divided by 0.40, you get 2. So she's doubling it every day. Okay, and she is doing this for 12 days. So I want to find the nth term would be the first term times the common ratio of n minus 1. Okay, on the 12th day, so I'm finding a sub 12, I'm going to have the 20 cents times 2 to the 11th. So 0.20 times parentheses 2 caret 11, you get 409.6. On the 12th day, she's going to get $409.60. Alright, so how do you write a recursive formula for a geometric sequence? Well, you would say the nth term is the common ratio times the previous term. An explicit formula is a sub n equals a sub 1 times r to the n minus 1. Okay? Alright, and we are at homework, so we are done. Happy homeworking, and I will see you next time.